Well, they're making their way up. My name's Tom Rose. I've been in the utility business about 45 years and doing consulting now, which means I don't do much of anything but other than advise folks. But we've got a great panel, and I guess the two speakers before me sort of set the stage for us. Between the moonshot and the power failure at Austin Airport today, there's a gap here. These are innovators that are helping us figure out how to get to the moon when it comes to the new transition of energy, because energy is in the biggest transition I've ever seen. I've been doing this 45 years, and when I came in the mid-70s, it was the oil embargoes, and prices were going up, and we were shutting down gas plants and building nuke plants and coal plants, and now it's in this new transition where we really, consumers, and are concerned about global climate change, decarbonization, and so on, and we've got to move in the right direction. The problem is you've got these three laws that kind of help guide us. And I guess it should say, fortunately, the law of physics, because electrons can only move certain ways and certain pathways, and you've got the law of economics. If it's not economic, then it's not going to work. People can't afford it. And then the third is law of man. Okay, it's how our politicians interpret what they want to do. And so you get these calls by politicians to do 100% decarbonization by 25 and 30, and we know in the business that we can move that direction, but getting there's a bigger challenge. So with that in mind, I'm going to let these folks introduce themselves. They're innovators in their own right, both with utilities and with new technologies. And we're going to go ahead and just get started once we start down at the end. And Byron, Rojas, give us about 2 or 3 minutes on you and your background and what you're thinking.
Thank you, Tom. It's very exciting to me be here. I am from Ecuador. I am the founder and president at DC Mirroring Company. Our company is bringing, we are offering AMI solutions using cellular technology. I have more than 15 years working, especially in cellular technology and smart metering. And I am engineering in telecommunication and electronics. And I have a lot of experience with different use cases in cellular space too, in IoT, machine to machine since 90s years.
Richard, go ahead.
All right, good morning. Richard Medina. I'm the interim EVP of Energy Delivery Services at CPS Energy in San Antonio, Texas. So we're the utility there. We serve Bexar County. We have about 900,000 customers and a little approaching 400,000 gas customers, so we're a gas and electric utility. We do have generation, transmission, and distribution. So a lot of miles of overhead lines, and we got a lot of miles of underground lines, about 8,000 miles overhead, and a little approaching 7,000 miles of underground. So it's just managing those systems. For us, the market is changing. We're seeing, the same thing, more distributed energy. We have to prepare our systems to host all that new capacity coming on. We got to figure out, how to use AI to help us manage the grid, because it's going to get more complex, and we see that every day. Everything's going digital. We got AMI meters, so we're trying to figure out how do we get all this information and make some smart decisions as we operate the grid. We do partner with a lot of research entities, so we do partner with the national labs on some projects. We are partners with UTSA in San Antonio, so we're doing some innovation projects there, looking at creating a digital twin of the city and figuring out how we can start leveraging all these technologies and the digital information systems so we can do modeling in a digital twin environment. So we're working with them on that. We also looking at AI forecasting of we got a lot of solar on rooftops, and, how do you use AI to figure out, how it's going to affect the renewables on the system? So we're working on some projects there. And then we also are working on, just as we put more inverter-based systems, it creates an issue for utilities as far as protection schemes. So we need to make sure we're protecting the grid and the public. So we're doing some research there on, how do you leverage AI to help you with protection schemes as the renewables hit the grid. So those are a few of the items that we're working on.
Great. Dan, you want to jump in?
Good morning, all. Happy to be here today. I have spent my career working in the electric utility and energy space, initially with EPRI doing a lot of pilot and research stuff in my 20s and moving on into commercial stuff, and seen a lot of advancement and transitions occur, especially around energy management systems and protection and control, where I have a long background. But I am now CEO of Available Power. We're a battery energy storage developer. We also have an AP, Available Power, cyber division. Our focus is purely on distributed energy resources. And I have a big announcement today, and we are really excited about what's happening in Texas. The announcement is that Daryl Thornley, who's here. Daryl, you want to raise your hand? If anybody has any questions, please talk to Daryl about the Greenport International Airport. It's 15 miles from downtown here in Austin, out toward Bastrop. And it is a very creative, ambitious project to build a private airport, still have U.S. Customs port of entry, so international, and completely net zero, highly resilient, focus on things like one of their first tenants is 160 megawatt Bitcoin operation, but also heavy involvement with the U.S. government. So it's quite an ambitious project that's been going on a long time. The vision came from a gentleman named Jim Carpenter, a very established developer in Austin. Been developing here for 52 years, so I think he knows what he's doing. And basically, Daryl is the project manager we've been working with. So we've teamed with the Greenport International Airport project and leased some land underneath the 345 kV line to build a initial 100 megawatt, 200 megawatt hour battery system, grid connected at 345 kV. And then in addition, we expect to expand that project up to as much as 400 megawatts and 800 megawatt hours over a phased approach. Obviously, that'll take some time. At this point, we're focused on building that first phase of 100 megawatts, 200 megawatt hours, again, grid connected. So we're very excited about that project. I think it's just being affiliated with Greenport, and the project there is very exciting for us as a developer, and we expect a lot to happen in the future there. In addition, for the last couple of years, especially the last 12 months, we've been developing what we call ERCOT 100, which is our goal is to put 100 9.9 megawatt, 20 megawatt hour battery packs, grid connected at distribution, obviously, in strategic locations around ERCOT to help firm up the grid and hopefully add some resilience to the system, give some flexibility to the system, and we think there's a lot of value there. So that is our primary thrust as a company, 100, essentially 10 megawatt, 20 megawatt hour battery systems, distribution connected. So we're busy, we're excited. Last I'll say, Richard mentioned AI. We have a major initiative being run by Glenn Goulias for us. He's in the back there, if you want to raise your hand. And basically, Glenn's out of the intelligence community in DC for his career. He's running our cyber effort to develop a fully AI-enabled, quantum-resistant platform for cyber. So this is not sitting there writing code. Those days are gone. This is more about architecture and implementing something that can be scaled. Everything I just said, 100% focused on energy, utilities, T&D. We're not doing general purpose stuff here. This is very specific to distributed energy resources, et cetera. So that's what we're about.
Thank you, Dan. Appreciate that. And that'll transition us over to Greg. You want to fill us in, Austin Energy?
So Greg Flay, Vice President of Technology and Data for Austin Energy, a geographer who got lost 30 years ago, wandered into the utility industry, and figured I'd be here about 6 months, but given that it was 30 years ago, that forecast was probably inaccurate. Worked within the technology area during the course of those 30 years in various capacities across investor-owned utilities, merchant generators, and currently with Austin Energy, a municipal utility. So we, as a municipal utility, have generation, transmission, distribution, retail customers, and a wide variety of technologies across all those areas. There has been a long history, started from Andres, of technology innovation at Austin Energy that I'm very proud to continue forward with today. We have innovative projects kind of across the board, from the moving our retail functions primarily into the cloud, to making use of AI and machine learning to detect various anomalies, both within the network as well as between meters and customer billing. We have an advanced distribution management system that came in about 2014, continues to grow with more and more modules. The taking the bite of an elephant one bite at a time definitely applies to how we develop that system. So we have a VVO, CVR, Flizzr, various kinds of capabilities. Obviously, we had an event last year here in Texas, and that's really been the focus of a lot of our efforts over the course of this last year and a half, looking at resilience as a service, looking at resilience hubs within the Austin area. So that's, to a certain extent, a large focus of our efforts right now is just getting resilience to where it needs to be. Obviously, notwithstanding this morning's event at the airport, which apparently operations are back up and running at the airport for anybody trying to get out of here later today. So,
thank you, Greg. Appreciate it. Terry, you've already been introduced, but jump in, Denton.
Sure. Terry Naulty, I'm the Assistant General Manager at Denton Municipal Electric. Long history, 40 years in the business from generation side. I'm an environmental engineer by training and wandered into the trading and marketing space after FERC 888 was passed, and spent most of my time working in the private sector for trading and marketing companies, and decided about 15 years ago to get into the public sector. But besides the issues that everybody here is dealing with on the technology side, I think one thing that we're, as a 100% renewable community in Denton, we've already kind of made the transition to a low carbon footprint, and we are now focused really heavily on using AI and machine learning to try to integrate our forecasting of renewable output with our load, as well as to integrate batteries and these large loads like the cryptocurrency mining operation, and large battery operations as well. So we're spending a fair amount of time on that digital front, looking at how we can maximize that for the benefit of our ratepayers and to keep our power costs low.
Great, appreciate it. Well, that gives you kind of an introduction across the board. I want to focus in on an issue that's pretty ripe right now in ERCOT and in Texas, and having to deal with everything from the edge of the grid at the AMI all the way to the centralized power plants, and where that's going. Because back when I started 45 years ago, there was this thing called transmission and distribution, and they seem to be converging somewhat as we go along. And someone reminded me in the wind industry 20 years ago, we're already putting distributed energy. We may be putting it on transmission grids, but it's 100 megawatt, 200 megawatt wind farms. It's not the centralized big nukes, big coal, big gas plants. We're going to keep going smaller and decentralizing, and that's part of our motto at CMG is decentralization, decarbonization, and digitization, because you've got to have all three if you're going to get to there from here. And so Tesla, I'm sure y'all are aware of it, Tesla has sort of initiated a workshop and a process at the Public Utility Commission here in Texas to focus in on aggregated distributed energy resources. And so I want to hear from each one of you really two things, what you see as the biggest impediment to getting to that aggregate, and we're talking about aggregating thousands, tens of thousands of residential battery systems, bigger battery systems like Greg's doing, and integrating that together and dispatching that and earning ancillary services or providing backup service for ERCOT. And I think that's an interesting thing because it deals with distributed energy resources, but then how do you coordinate that with ERCOT, who's responsible sort of for the overall, with the utilities that are responsible for their own networks? So I wanted to start, you want to go ahead and start and talk about AMI and what potential that may have?
Yes. At this hearing, we think that the energy meter is essential. In the grid is for financial of utilities, of course, but it's not a critical mission. It's not used right now. We think that it's necessary to create a new features for smart meters in the grid. At this hearing, we are working to incorporate more features using broadband technologies. Right now, our meters, we have a solution. We create devices inside what is installed inside in the meters, and they are more than network interface card. They have a robust and high application that we are integrating with the grid. The idea is of easy mirroring we are working right now is in the AMI solution. The architecture of the technology is you have right now system, telecommunications, you have meters, but right now we are creating intelligent distribute in the meters. We are creating a new, for example, I would like to explain much better, sorry, because I am new here in the United States, but the meters right now are using only for billing purpose, and of course they have the system, the YAM system, are receiving information and collection information using narrowband technologies. But right now with broadband, like LTE technologies, it's possible to do peer-to-peer networks. I mean that the meters, they can exchange information between them. With this, we can aggregate, distribute intelligence in the meters. We are working in order to save money, for example, to utilities in Latin America. We are creating in real time load balance in the grid. This is a very good opportunity to use broadband technologies in the grid.
And I'll help Byron out just a little bit. What he's really talking about is moving from AMR that's used for billing and is pinged on a 15-minute interval to real-time metering. where you have sensors and you can actually know what's going on at the customer premise in real time and can control the exchange of telecommunications. And that's where you get with the broadband LTE system, being able to communicate and carry all that data. Because as any of us know that have put in AMR metering and AMI, the amount of data is overwhelming compared to what we used to. And if you think about it, before 2010, most companies and utilities went and physically read a meter, and it was one data point every 30 days. Okay, you go to 96 data points per day with a 15-minute interval. What Byron's talking about is thousands per hour. Okay, and that's a big deal, but you can see how significant that can be as the edge moves toward the center, as the customer premise becomes engaged in this process and this dance and this orchestration of moving electrons back and forth across from centralized to decentralized systems.
Yeah, another thing that is very interesting in real, because right now in the narrowband technology, it's not possible to create a distributed intelligence in the network, in the elements. And right now we want to become the meter in an active part in the smart grid. This is the interesting thing, that because it's a powerful sensor, but it's not using completely.
Right.
Yeah.
No, it's fully,
yeah.
The whole idea is you're going to have all that intelligence at the edge of the grid,
and
in addition to the central.
In the central system, when you are in the computer system, right now, with narrowband, you need sophisticated software, robot software. You need a lot of software in order to take decisions, but need to collect first the data. But it's not possible to predict in real time. This is another thing that is important to have.
Absolutely. Predicting the future is always hard, but it's real hard when the weather's involved. So Richard, why don't we jump in and talk about your system?
On our system, we have an AMI solution, and we are at the 50-minute interval. I think from a utility operations group, we would love to have the real time. I think it's a little challenging, so our system is a little older. So we are going to be looking at what's the next evolution of AMI metering and the two-way communications and all the real time to take advantage of controlling all those systems behind the meter. One challenge I know just for most utilities is that when you start putting those resources behind the meter, which customers have today, and we start trying to aggregate, it becomes how are you going to settle that with ERCOT? So the metering is going to be a challenge just for figuring out how do you settle all those flows and settlement rules going to ERCOT. So I think that's going to be an interesting challenge going forward. The cyber security piece, once you start controlling all and aggregating all these, I think it's an issue too that utilities need to keep an eye on, just because people are going to want to be using their Wi-Fi systems, and are we going to have to overlay another communication system to control, and then connecting all that through DERMS and energy management systems, I think is important. So there's a lot of work it sounds easy, just creating the virtual power plant, and it's exciting, but it's still challenging. So there's still a lot of work to.
So how many meters do you deal with?
We have 900,000 meters.
900,000. Yeah. So if you take that one problem and multiply it times 900,000, you start seeing the scope of the issue. I'm going to jump you just a minute and move to the other utilities and let y'all talk about the same kind of setup for aggregation.
Yeah, it's so the data problem that you mentioned with regard to AMI is significant. We have a pretty full deployment of second generation AMI infrastructure. And just management and making sense out of that sheer volume of data is quite challenging, because you're not only going to the 96 times a day, but anywhere from 30 to 100 different data points coming off each read. So it's the data alone is quite challenging. Probably the most significant work that Austin Energy's done within this area is the Austin Shines project, where we looked at various energy storage systems in various configurations, solar, few other intelligent controllers, inverters, and being able to, from a software standpoint, balance the physical needs of the distribution grid at the same time as you're trying to optimize, especially on the battery side, the financial benefit. And stacking all those benefits on top of each other is quite challenging. So I think that, in addition, I'm less concerned with the more technology arriving on the scene than I am with the our ability to actually consume and make use of that, and make sure that the regulatory constructs and so forth are kind of, keeping pace with all of the new technology innovation that comes out. That seems to be a little bit lagging.
So you're suggesting that the regulatory models run as a lag to the technology?
I think it's always challenging.
It's always the case.
It's always the case. Yeah.
Terry, jump in on city.
Yeah, so we have kind of the first generation AMI system, and we recently were looking at rolling out AMI for our water system as well. And through that process and all the technology development, we've delayed the project now because we want to make sure that we're understanding how all this will work together, and that is a large investment, so we want to make sure we do it correctly and get the right software to be able to manage all this data. What I will say about the aggregated distribution is, it's an educational process, because I'm concerned about the value proposition, not only to the providers of the technology, whether it's batteries or other type of DG, but to the ratepayers. Because like solar, rooftop solar, we don't want to create a subsidy program where, we have the bulk of our customers paying for technology innovation to those who can afford to put these technologies on their homes and businesses. So I think we need to keep our eye on that value proposition and make sure we don't create a subsidy. Yeah, we want advanced technology, no doubt, and there should be incentives, but we have to recognize that it's a very diverse customer mix with lots of socioeconomic pressures on all of our customers.
Great. Yeah, it's such a challenge, but it's a day-to-day, but it's a 5-year plan challenge in addition. And Dan, I wanted you to talk a little bit about, to me, the very unique role that a battery or any storage system has in the electric network, because up till now it's pretty much been real time. I mean, when you flip a switch on, a generator comes up and puts more electrons in the network. And I'm always, from a business standpoint, saying electricity has a shelf life of 1/60th of a second, or one cycle, and it's true. And so when you start looking at the challenge of merging distributed resources with centralized resources with your networks, what's the one tool that you have that's available to you that can help you go source, sync, back and forth, and move that power back and forth along that grid? So jump in and talk about that.
Boy, I should step back just a little bit.
Sure.
When I started my career, I worked with EPRI on the utility communications architecture, which became IEC 61850, and in fact, CPS was one of the leaders in the country on pioneering that technology, so that was pretty interesting. That was really an aggressive program that really grew and became something. So utility communication architecture was about interoperability at its heart, and we created this protocol called IEC 61850. Even before that, I was one of the first 3 that designed, implemented DNP 3.0, level 1, 2, 3, SOE, the whole thing. So I spent a lot of time down in the mud on those technologies, brought 15 products to market around that for over a 25-year period. And at one point, I was North American system architect for Riva. We had most of the control centers in the United States running our platform. So I've got a really long background in this exact topic. And that led to me writing a patent in 2008 on distributed hybrid renewable energy. It's US 8260469. And it got issued in 2012. It took 4 years. And it got adopted by Duke Energy, FP&L, and it's been used pretty heavily around the world since. And its focus is on virtual power plant with distributed energy resources. So I've been at this a while. That led us to look at this problem from a standpoint of how do we actually add resilience, robustness, reliability to the system. And that, of course, led us to batteries. So, as Tom said, it's clear they add a new dynamic to the formula that we're trying to address here, especially as we integrate, interoperate, and start going to real-time trading. We implement AI on quantum. I don't know where we're going to go. That's another level of technology that we don't really fully understand the impact of, in my opinion. But I think that's clearly Gen 2 on this system, and something that's going to take the next 10 to 20 years to evolve. But it's going to be very exciting to see how well that works. You have to give it tools to operate, though. So when you think about an AC system like we have now, I call it the legacy system. Probably a lot of people are going to laugh at me for that. But basically what's happening is the generation responds to the load. And of course, it has to ramp up and down appropriately, and it's very complex, especially across 900,000 meters. I mean, this is really nasty complexity. You multiply that across our whole nation and our nation's grids. Here in Texas alone with its own grid, it's really complicated. Computers by themselves can't do everything here. As Tom said, we need physics, we need tools, we need human interaction. We need to really be able to respond to all this. So when we look at this whole picture, I think it's very interesting to think in terms of how do we optimize the grid. If we could start having the batteries respond to the loads, I'm being futuristic here, and simply use the grid to charge the batteries, I think that would be a really logical next step. And that's what we've done in electronics. So if you look at all the products I've designed and worked on for a long time, hardware, software products, it's all about the power supply first. You have to have power before you can do anything, and it has to be right, and it has to be regulated. And what do? We go to DC. You would never use AC out into a circuit. It would be crazy. So it is very realistic to believe in the future, and I don't know when the future is. It could be 100 years. I think we're going to have a battery front-ended system, and we're going to have more DC-connected loads on that system, and it's going to build a very resilient system that doesn't have to ramp up and down the gen sets, because if you think about it, if you're just charging batteries, and the batteries are handling all the load variations and all the reactive loads on the system. Again, I'm not pretending this is something we can do today, but in my mind, that's where we could go, and we could end up with a very stable system, and all our generation could be optimized around that sweet spot that they operate at to charge the batteries.
Yeah, no doubt. And so you're seeing the decarbonization of transportation using those same batteries. Yep. When you open up your laptop, what power supply are you on right now? I mean, you're probably not plugged in, so you're working off of batteries. My smartphone's working off batteries. So battery storage of electricity is key. Now, it runs, up until now, it's been bumping up against the law of economics. Law of physics is fine. Okay, it knows it can be charged, it knows it can be discharged, you can control it with AI, you can do lots of things with it. But the law of economics have been kind of saying, banned. I don't know if I can afford it. So I want each one of you to talk a little bit about your idea, looking forward 5 years, 10 years in the future. What you think, because we've had a business plan in the utility business for 140 years. And it was, we're going to charge you so many cents per kilowatt hour that you use, or the demand charge of how many kW you use during peak load. And, you know, I've got to say, outside this room, there aren't many people that even know what a kilowatt hour is. And I help friends and family all the time, and they're going like, what's this kilowatt hour thing, you know, that I'm paying for? And I'm going like, well, you're not really paying, yeah, you're paying it based on that, but that's the accountant's way of getting their money divvied up. But I want y'all to talk about futuristic business models and use cases you see going forward that might be something of interest to these guys, because if you don't have the money, if you can't afford it, it's hard to build it. And if we can't afford a green, you know, a cleaner environment, reliable environment, a resilient environment for electricity, then we've really impacted the economics of our whole society. And we don't want to go backwards on quality of life. We want to go forwards. So why don't we jump into that? And let's start over here with Terry. What do you see kind of as your business model been from all over the place?
Well, I guess, you know, I go back to the value proposition, and, you know, until we can find ways to change consumer behavior and how they use energy, we're probably not going to send the right economic signals to the marketplace to get the right technologies in there. So, you know, we've seen some utilities in TVA, for example, have gone to a pure demand-based rate structure where it's not a real-time price, but it's a demand-priced environment. And boy, it's changed a lot of behaviors in some of the communities that have adopted that. I think that's a good start to try to drive the behavioral changes that are needed to get consumers to consume energy more economically efficient. A long way to go, and very, very tough. I couldn't imagine, we talked about AMI meters and things, you know, certainly our system's not ready to do that. Would it require a lot of investment for us to be able to do that now and to fully integrate energy storage into our system, even though we are 100% renewable already. Very, very expensive, I think, to integrate it.
But how expensive is it to implement a line charge or demand charge like you're talking about?
Not expensive to implement it. It's expensive to put the metering and billing systems in place to be able to implement it.
Right.
And in communities where it's been done, it's not been well received by the communities as well, because it does require just a quick, you know, little town in Kentucky that did it, and every morning they would send out a price signal on kind of what the prices would be in the middle of the afternoon in the summer. And the residents, many of retired residents, would get that information and think they have to turn their air conditioners off in the middle of the summer. And so they did, and then they went to the mall and started walking around the mall during the middle of the afternoon. And then the mall people, vendors got upset because they weren't buying anything. And so they ended up having an anti-loitering program for the mall. And then what happened, they decided, well, since it's a municipally owned utility, we're going to go down to the courthouse and we're going to sit in the halls at the courthouse so the mayor and his staff will have to walk around us. And that's what they did. They got their lawn chairs and they went down there and camped out in there. But the utility stuck to their guns, and it's been pretty well accepted now, and it has changed the behavior a bit.
Sure. And I think of, you know, people going up to taking their vehicle up to get gasoline and filling it up with gasoline. They see immediately what it's costing them as the dial's turning. Electricity, you don't find out till 45 days later typically what's going on, and unless you're very sophisticated, which 99% are not, they don't care. I mean, it's not that they can't learn it, it's just that they don't want to spend the time to learn it. And so you have, I missed the one law, there's actually four, it's called the law of unintended consequences, and that drives a lot of things too. So Greg, jump in. Business models.
Yeah, so there's two aspects to this that occur to me. The first is the economic question of kind of fixed versus variable costs, right? And this continues to move us down that pathway. You know, I think many of us remember when, you know, a phone had a small monthly charge, and then you were charged for long distance, for those who remember long distance charges. And now you just have a fixed amount, right, that you're paying a fixed fee. And when you look at the you know, move toward more renewables, battery, those kinds of things, it's less and less being determined by fuel costs, which is the variable part. So I think that one of the challenges that we have with these new technologies that exacerbates an already existing problem is moving from the bulk of the bill being a per kilowatt hour charge to the bulk of the bill being more fixed that reflects more the actual costs of operating a utility. So I think that's one aspect of this that comes to mind. The second is organizationally, batteries are really tricky organizationally. Apart from the technologies to run them, is who runs them. So battery programs started off, at least at Austin Energy, as a customer energy services program. And as battery became more and more substantial, like demand response, it's now shifting. Should it be controlled in the control room? Should it be controlled by our energy market operations area? Is it a financial thing? Is it a physical thing? And obviously it's both. So kind of going back to the distributed energy resource optimization engine that came out of the Austin Shines project and the challenges involved with that, I think that we have kind of similar organizational kinds of challenges that we need to address as organizations.
Right. Yeah, no question it's a challenge. You can go?
Yeah. Well, this is another topic near and dear to our heart, obviously. From an economic standpoint, I'll just put it this way. We have an auction going on right now. I can't reveal much detail about it, but we are selling a batch of our projects. We're a developer. We sell batches of projects. So call it a portfolio of projects. And we have 52 qualified bidders right now, going on right now, from trillion-dollar, multi-trillion-dollar funds all the way down to small shops. So, as far as getting the money, I've never seen anything like this. And I was involved with TVA. We built the nuke plant. We did some things along the way. I've never seen anything like this. So this is really interesting. There's an awful lot of money in the private sector ready to invest in this model, and they're doing it at merchant risk. So it's very important to understand. The markets are saying, this is 52, I won't name them, but you can imagine who these are. These are the biggest, all the way down to some small boutique shops. And, they are so aggressive because they believe that the merchant risk just is obvious within the battery investment sector. So there's a data point for us to consider. We would not have gotten this response a year ago. There's no way. And we got this response prior to the new bill that came out of the feds. So of course that only amped up the interest even more. So I just want to emphasize that as far as getting the money to build these projects, we have, I think, at this point, an unlimited amount of money available. And, that's private sector, merchant risk, because Texas is so far out in front. I think it's clear Texas saw this coming. They're having some pain because, you're making drastic changes in this transition. I think it's clear, again, that Texas is way out in front of the rest of the country and is really going to reap the benefit of it in the long term and make everybody else follow what's being done here because the economics are here. So that's our view.
No, and I think the economics of storage is coming on, especially, I believe, before 3 or 4 years ago, people, the consumer and politicians and elected officials took reliability sort of as a granted because we had all these integrated utilities, we're making sure your lights were on. And now that we've gone to competitive markets and more open markets and more free markets, that's not a given anymore. And you pay for reliability, you pay for resilience. And I think people, if you're in California and you're on your 14th straight day of flex, what they call flex load, which means turn everything off, or you have fires and you're turning off whole networks.
Oh, yeah.
I think folks in Hawaii, California, and on the East Coast would more than welcome to pay a little extra for reliability. Richard, do you want to jump in?
Yeah, great discussion. I agree. I think, rate design is going to be key in the future, but we have to be mindful that, at the end, there's customers on that other side, and not all customers are as engaged in those behaviors. So I think we're going to have to develop the tools to help our customers. And so that way, I mean, everybody's busy in their daily lives. They have their jobs, and I don't think they want to be thinking about energy prices and what's a kilowatt hour. So for us, I think, you know, the future is going to be battery storage at the home with EVs, and figuring out how do we have a control system that we could sell resiliency services with those resources, and the question is who owns them, and then how do we, you know, as we put more renewables on the grid, you know, there's those peaks of renewables are going to be at different times so that we can push energy, store it, and then use it when we need it, and then create that resiliency package for customers and reliability.
Right.
And I think it's important. And the tools that, you know, kind of automate everything for us is going to be important, but I mean, that's futuristic stuff where, you know, the grid is just talking to all these devices and turning things on and off and pulling power and settling all those energy transactions is going to be interesting.
And Byron, why don't you jump in?
Yeah, we think at this meeting we think that it's necessary to create value to consumers, create new opportunities for clean energy vendors too. I think that it's necessary to change the business model, the current business model. Right now, the energy is sold up to the meter. We think that it's possible to sell energy for appliance, for example. We are thinking in this concept right now, and because this is a very good way in order to create incentives, economic incentives in order to adopt clean energy, because it's a big challenge. We know that it's a big challenge, but it's possible to create right now with the current technology, with the existing technology, using smart meters, using broadband technologies, using artificial intelligence. But this is a very good point that is necessary to discuss in the future. Yeah.
Yeah, I think that's absolutely right, and I think business models will change. Matter of fact, Richard, you and Dan may want to go talk to Austin, the Austin airport, about what you do out there going forward. And honestly, I don't know whether the problem was a systems problem or internal to the airport network or whatever. Kind of doesn't matter.
Right.
Shutdown is a shutdown is a shutdown, and nobody likes that. I mean, that's in today's society, think 50 years ago, that wouldn't have been as disruptive. But today, everything, I mean, works off of electricity now. And as we go to more electrification with vehicles and other things, resilience is going to be even more critical. And so I want you to comment on a business model that I've had in my head for really since '99 when we started opening the market competition here in ERCOT. And it's at some point when consumers they don't understand the network and what's going on, but they understand their bill and understand how much they pay and understand they just want to have lights and air conditioning and heating and what have you. Do you see someone coming in, and I won't name a name, but I have one in mind, that comes in and basically says to the customer, and is a retail electric provider, along with a battery, along with solar, and coming to the customer and saying, okay, I've looked, you know, if you let me look at your bill, give me permission to look at your bill, I'll look at that average, and you're paying $300 a month average over the year. I'll do that for $200 a month. And you just pay me directly, flat fee, $200 a month. Let me put in solar, let me put in battery storage, and I'll make money off all of that. Do y'all see that as a viable option? Not today, but 5 years down the road, 10 years down the road. Go ahead.
I think that it's necessary to incorporate to appliance manufacturing in this discussion too, because I see the energy like telecommunications. Right now, I think that we can to understand and compare, for example, megabytes with kilowatts hours. If you are looking, for example, this, if you are doing this comparison, it's possible to find a new opportunities in the market, in the electricity market. This is a very good comparison. Another very good comparison between telecommunications and electricity is the bandwidth with the power width. Power width for us is the capacity that the electricity system, the wires, has right now. And bandwidth in telecommunication, you feel when you use your cellular phones, when you use your computer using internet, for example. This is very good.
Yeah, and I think when you look at smartphones and you look at telecom, I think we can learn a lot from a business model standpoint in the telecom industry and where it's moving, and talking about having less variable cost and more fixed cost, and taking that market risk of the flexible, the variable cost, and packaging it all up for the consumer, because the consumer just wants their energy. They just want their electricity, and they don't want to be gouged too much. They want to pay for it, and they want to. But one of the valuable things that's happened here in Texas and other places, California, is I think people are recognizing the value. When you don't recognize the value of something, until you don't have it. And that's when the value kicks in, and you're going like, man, I wish I'd, instead of 4 days freezing last winter, winter before last, I wish I'd have had some backup power. And I know people that are putting in Generac full-scale natural gas generators at their homes, in addition to, and building virtual power plants. And so that's a huge shift in the way we think about utility business. So I do think telecom is one. Richard?
Yeah, and I mean, I agree with your analogy there. Leveraging what happened with the telecoms is important to kind of see how they went from, I don't know how many people still have a landline at their house. I mean, nobody, all the kids have cell phones now. So there is stuff we can do to kind of look and predict what's going to happen, but I think there is going to be a point in time where, a battery solar package can power your house, and people will be talking about off-grid solutions, and the utility can be there as a backup to that. So there's lots of opportunities that we need to keep an eye on, and even determine whether is that the model we want to be in. Maybe we're the ones out there pushing a battery solar storage and that's capable of pumping power back to the grid, and then leveraging, community microgrids. Just it makes it easier, since you have all the wires there, to put a smaller battery to create a community microgrid if everybody has distributed energy resources behind the meters. So it's important.
Yeah, jump in.
Well, this is exciting. I built a cottage during the pandemic in my backyard for my own use, because I couldn't be that bored for 2 years. So, so I built this thing, and I built it very energy efficient and really paid attention to the details. And my intent from the start was to build a DC off-grid cottage backed up by grid if necessary, or a generator, whichever. And so I did that. I used automotive technology primarily, all off-the-shelf stuff. I didn't invent anything. Just hooked it up. Actually, my son Ben, who's here, and I did this together. And it's running. It's about $2,500 in parts. We did all the design and work ourselves. It's low voltage, touch safe, class 2 wiring, no electrician required, no permit required. Town was all over it because everybody was interested in what I was doing, but it wasn't required. And it's running right now. 4 solar panels, 100 watts apiece, 400 watts into LFP batteries, all off the shelf. It sounds like a ridiculously low amount of power, but when you've got a building that's that tight, I got a 1,500 watt electric heater, heating 512 square feet of space in Colorado. Last year it was about minus 15 degrees outside, and I was warm. And so if we start looking at batteries differently and realize what we can do, let's look at lighting. I've got all my lighting. It got so cheap, I don't shut off my perimeter light anymore. I couldn't afford the switch. I'd never get a payback on the switch to shut it off because they were DC switches. So you know, looking at it, you're talking about, you know, 20 watts of perimeter lighting around my whole yard. You're talking about inside the building, a total load, including my server running. I have a pretty nice server, about 800 watts. So about 1,000 watts peak inside the building, except when the heater comes on. But the heater only comes on, this is the tricky part, the heater only comes on for 10, 15 minutes because it's a tight building, small space. So let's think about that. You've got, let's say, a 3 kilowatt hour battery, and you've got a 1,500 watt heater, but it only runs for 15 minutes. You don't have a problem. Now, if you don't have solar, you got a problem, so you got to have some way to charge it if the solar's not available. And of course, you know, I'm a grid guy. I still believe the grid's very important, and we need the grid. So I've got a system that would auto throw over to the grid. But I'm talking about all parts, fuses, cables, electronics. Amazing power electronics have come out in the last year. $2,500 installed.
Oh,
So
no doubt. Now,
changes the game, right?
Yeah, individual breakers that are Wi-Fi connected now.
So you want to talk
Yeah.
cheap?
Yeah.
I got free power now for probably the rest of my life, I would imagine. You know, however long I
It
live.
costs you something up front. It's kind of like my
Yeah.
wife telling me we get free dinner at the country club. You got to pay for it up front.
Well, it costs $2,500 though. Think about what I'm saying.
No, I
It costs
understand.
$2,500.
I'm totally
Yeah,
with
that's-
you,
this is
man.
getting
I'm
darn
totally
close
with
to
you.
free. So anyway.
You're getting that law of economics in line with the
We
law
are.
of physics.
We are. It's hard to turn that down.
And 50 years from now, I mean, how many devices do we have in your house that are running off AC that you have to put them through a DC transformer to convert them? I mean, almost all electronics, certainly battery setup. So you're going to see more DC as time goes on, more efficiently, and especially as refrigerators and other devices can switch over to that.
Q&A.
Yeah, Q&A?
Any questions in the crowd?
Come on, lay it on us. What are we getting wrong?
All right, I'll get you started real quick. So
Okay.
I need the utility guys to help us understand what happens when half of the F-150s become F-150 Lightnings, like mine, and I plug to the grid, right? And I run my house from it, and I charge it at work. So I go to work, charge it for free, and drive home and run my house. What's gonna do to the grid, Richard?
Well, of course, it turns into another rate issue, but you know, it is possible the same thing. If we have too much solar, maybe that is the solution, that you charge during those peak hours to pull the solar off the grid and then redistribute it in the evening. So, I mean, that is an option. So.
Terry?
Yeah, it's a rate issue because those fixed costs of the poles and the wires and the transformers that you would need when you can't charge your lightning for free and then bring it home and run your house, somebody has to pay for that. So it all ends up in a rate issue at some point, and trying to recover what's a pretty capital-intensive business, providing this resiliency and reliability that we all expect.
Yeah. Greg?
Well, number one, you work for a very forward-thinking company. Gives you free charging. That's nice. But yeah, I would agree with the other two gentlemen. It boils down to a rate issue because it's not KWH anymore.
So if I go back, if I look at the bill today has fuel split up from everything else, but it's really not, that's everything else should have a lot more granularity, right? So I should be, like in the cable industry, you're paying for the router, you're paying for the package on the data, you're paying for the programming, HBO, whatever. And the utility will have to go through the same thing, right? Eventually, I will have to pay for just being connected to the transformer, just having backup power, having whatever, right? I mean, can you talk a little bit about that? And this is coming. I think it's inevitable, right? I mean, am I right?
Yeah, let me just, only because I just went through this analysis for looking at our rooftop solar rebate programs and our buyback. In Denton, because of cost of service studies, it costs us $62 a month in fixed charges for the average residential customer. Now, we don't collect that, you know, our facility charge is about $8.50. And the rest of it, because of rate design, is collected on a variable basis in order to drive a behavior of conservation, right? Use less, control your costs. But that's the underlying issue is, you know, we have to recover those. Now, if we fully depreciate our distribution systems and our transmission systems and we replace it with a standalone DC system, then we don't have to recover those charges any longer. So.
Question?
Yes, hi. I'm Sasha, and I had a question also related to electric vehicles. So I live in California. I would pay for reliability right now. In fact, I checked my, my circuit number. I'm number 8 for rolling blackouts. And the major factor right now is just heat, so therefore AC. And California has 16% electric vehicles. As we're getting more and more of that, I want to know how close, and this is for the utility panelists, how close are we to vehicle to grid? How many years out? How serious are those discussions? Maybe not.
Yeah,
Maybe not at all.
Until vehicle saturation? I'm sorry.
Vehicle to grid being part of the answer.
Grid integration.
Leveraging the batteries on the vehicles for grid stabilization.
Yeah,
What's the prediction on when is that going to happen?
Depends on where you're at. I mean, here where we sit in Texas, and you know, it's a little different than California, but I would contend that it'd be a lot more difficult to tell you as a EV owner that I'm going to tell you when you can and when you can't charge your vehicle. So I think that's a societal issue that we've got to wrestle with. I don't know how you get around that question to solve to fully integrate.
Go ahead, Dan. Go ahead, Dan.
Yeah, I mean, I know that's an interesting question because I think all utilities are looking at when's those tipping points are, you know, for electrification and EVs, and I think we were also looking at control systems where how do you know, the vehicle to grid chargers are still expensive, so I think that's a limiting factor there. But as that becomes cheaper, then I think it's going to open up the door there, and that's where all the aggregation and things come in, because there should be no reason why you can't call on a battery or your car, as a car is a battery, a moving battery, to go plug in and charge, and it's just creating those billing systems and settlement systems to take place. So as I know FERC put out that FERC 2222, I mean, that's all part of aggregation, and I think it was put on pause because of the, you know, how are you going to settle all these things, and ERCOT's now looking at it, so it's just it's coming.
So, a couple of things. One is, now I'm going to contradict what I just said earlier and say that you know, innovation's great. I've done a lot of that in my life. Still am doing it. I hope I'll do it until I'm not breathing. But in any case, it's complicated. And you can't just hire an electrician to come into your house and start playing with a DC microgrid. We're a long way from that. You know, we could look at training auto mechanics to work on DC microgrids every day, and that's happening, and this is an evolutionary process. But let's look at it that way. I don't know why we're not putting batteries at the head of every feeder, every significant feeder in every neighborhood, and moving that complexity out of the house. I'm not a proponent. Having done it myself and looking at it really carefully, and it's cost effective, you have to be really sophisticated. You got to be an electrical engineer. Okay, you might not be, but you got to really be into it. And there's not a lot of people that are going to do that. And you can't even hire people to do that. So, but the utilities have these substations. They got fences. They got staff. They got sophistication. They got, you know, more and more automation. Why aren't we putting grid scale connected batteries at the head of these feeders and securing neighborhoods at the feeder level, and then moving that system? Now, you know, there'll be individuals like me that just want to try stuff because it's more or less a hobby for me. It's not my business. But I do learn a lot when I do those kind of things. And it's the same physics. So if I look at this, I'm wondering, why don't the utilities want to really embrace these batteries at the feeders and get out of the houses So what's the thought?
For us, the thought is both. It's going to be both. And that's why earlier when we were talking about resilient communities, you're going to have electrification in the home. You're going to get battery storage in the home just for resiliency purposes. You're going to have the cars plugged in. So as long as the auto manufacturers allow that vehicle to grid charging without damaging their warranties, I think it's going to happen. And then for us as a utility, yeah, we want to plug in batteries at a substation, but one substation transformer for us is 100 megawatts. And so it serves a lot of load. So as everybody distributes that piece, then the batteries that we have to put in is smaller. And that's where I think it's going to go.
Yeah, I'm going to ask Tom Rose, my brother, 45 years at TXU, and him and I pontificate on this and do work with utilities. And Tom, when is this going to happen? When as one of the co-authors of deregulation in Texas in the '99 law, when is this going to happen? 5 years from now? 3 years from now? 4 years? 20?
It's happening already in certain regions. Okay, there are certain places where there are higher than normal concentrations of electric vehicles. They're normally affluent areas, affluent feeders, where you're seeing PVs going in, you're seeing electric vehicles being plugged in. It's happening on both coasts right now, and we heard from Carlos earlier, and we've heard from California, and the first real indication was 6-7 years ago in Honolulu. They were having a huge problem with voltage swings and power quality issues at the distribution level because of it. And they didn't have any kind of AMR or AMI, so they didn't know what was going on at the customer premise. But it's starting now. I mean, I have no doubt in my mind about it. Now, how fast it progresses is going to depend on this whole law of economics. Okay, is it cheaper to go put this in than the status quo? And that's when the business models will start changing. Okay, that's what happened in telecom when we went to kind of unlimited, usage of data because people wanted unlimited use. They didn't want to be restricted. Okay, but they also didn't want to pay too much, so competition drove that down. So I think in Texas you're going to see it, but it's going to be based on the penetration of EVs and PVs and batteries within those distribution networks. And when you get the penetration high enough, you've got to deal with it. As a utility, you don't have a choice at that point.
Right. Any other questions? Anybody? Go ahead.
Thank you. Troy Helming, CEO of Earth Grid. I also live in California, and I don't notice blackouts. We have a Tesla Powerwall in our garage. But my question is kind of more on a macroeconomic view. Is anybody working on any HVDC lines in ERCOT to try to improve the grid and add more grid ancillary benefits?
Sure, do y'all want to jump in, or y'all familiar? Well, we have 4 HVDC lines routing that connecting us to Mexico and to Southwest Power Pool. They're relatively small, 800 megawatts total. There is a new proposal going from, I believe it's the Pecos to El Paso line that's being proposed by, I'm drawing a blank on the name of the company, but they've currently proposed approval for a 1,500 megawatt HVDC line connecting ERCOT into the Western grid. And you've also got FERC, who is pushing, and frankly the state commissions are pushing for more interconnection for reliability resiliency purposes between the various grids. And the Eastern interconnection, because you have an Eastern interconnection, but it's made up of lots of control areas. And you've got MISO and SPP and New York ISO, but they're looking for more interconnectivity between those systems. And the same out west. And so it's looking like over the next few years that you're going to see more interconnection of transmission. And I think a lot of it's going to be HV because it's more controllable than AC, asynchronous systems. And so it's kind of like having a valve in the pipeline. I can shut it off, I can turn it on, I can feather it, I can change it. And that'll improve resilience and reliability if it's done right. Anybody else want to comment on that?
Any other questions? Oh, here we go.
In your transmission systems, there's about 10 to 15% power loss, I think, moving it through. And superconductors have almost no loss at these cryogenic temperatures. So is anybody working on superconducting transmission lines? I'm thinking long distances from where we can put renewable energy into the thing. And what would it take to get a superconductor line going?
Mm-hmm. The answer is there have been numerous attempts across the world to get superconducting conductivity to move power. The number is closer, depending on the region, to 6 to 7%, but instead of the 10 or 15. But it just depends on what part of the country. If you're out west, it can be 15 easily. So the superconductor is a good solution from an energy use standpoint. It's simply the cost. It bumps up against the law of economics. The physics is there. We know how to do it. We know how to cool a line down to 273 degrees Kelvin. We know how to pass electricity through it with no loss at all. It's just that it costs, 100 times more than a regular line. And so that's where you're running it. So it's running up against the law of economics. But the fact is, most renewables in remote areas, most load centers are in high density areas. Okay, so I think it's clear to everybody in the country that if we're going to move to a more decarbonized market, you've got to have more transmission. And is it superconductors? Is it DC? Is it asynchronous lines? What's it going to be? And I think economics is going to drive it. Andres?
Would anybody like to comment on the technology of transactive energy and blockchain transactive energy in particular?
Okay, somebody on the panel wants to talk about blockchain transactive energy. You're doing peer-to-peer metering, or trying to.
Oh, yeah. I think that it's possible to add blockchain technology in the meters, and because will be very interesting to connect power plant clean energy vendors with consumer, with appliance, and blockchain is a very good technology in order to create virtual pathways. And with this kind of technology, it's possible to create a new business model. This is the idea, the principal idea, that using blockchain technology and comes together with meters, with the smart meters, and broadband technology is essential in this part. Yeah.
Jump in.
There is a group called Energy Web Foundation. My chairman was one of the founders of that when he was with Rocky Mountain Institute. They sponsored it initially. It's got quite a following, and it's applying blockchain into the community. So you might want to look at EWF. I think it's EWF.org or something like that, and check it out if you want to know more about that.
Well, there's one company up out of Pennsylvania, Reading, Pennsylvania, America PowerNet, and they've been using blockchain for the energy transactions, trying to get it down to one-day settlement periods between.
They use Power Ledger's product.
They use Power Ledger.
Power Ledger will be here. Is Elena here? Elena?
And so that's coming. I see it really helpful in the financial transactions to keep up with the actual electrons and the settlement systems. It's a very efficient model.
So last scenario, because this is my life, but we're going into the next. Go ahead and flip the slide. We're already eating into the get together with the panel and come and get their business cards and take a selfie. Last scenario, there are two ways of solving this decarbonization challenge. One way would be, the easiest way, in my opinion, would be you take Delaware. The state of Delaware is 1,900 square miles, roughly. Half of Delaware, right? So 900 square miles. You cover it with solar panels, all of it, and you can replace the 1,100 gigawatt hours that the United States uses today. Okay? So I'm challenging the president to take half of Delaware, cover it with solar panels, put his money where his mouth is, and then build the transmission lines to everywhere. Is that scenario possible? Could be Delaware, could be Utah, could be Texas. Could we do that? Could we just cover 900 square miles with solar panels and send energy everywhere?
In my experience, it depends on who the landowners are and whether they want it or not.
And those
And
transmission,
can you get them to agree?
And so for the audience to understand, those new transmission lines, probably not even 1,000 kV, but more like 2,000, 3,000, 5,000 kV lines would have to go through somebody's backyard.
Well, and the solar panels themselves. I mean, I've worked on several solar projects, and one of the biggest impediments is getting more than, not many landowners have, more than 500 or 1,000 acres.
Right.
Okay, and so getting a bunch of landowners to agree. Now, wind farms, I can still agriculture, I can still mine, I can have oil and gas wells. But with solar panels, you pretty much take the use out of you change it from an agricultural farm to a solar farm.
Just to give you an idea, there are 660 acres, I believe, in 1 square mile.
Right. And so
We need
it
800
takes a lot of
800 square miles, 900.
and that's been the biggest impediment from my standpoint.
Right.
Yeah.
So the other way that this is getting solved is distributed. And one house at a time, solar panel in every house, power wall in every house. And do we see really a hybrid here at all, or are we really going edge because of the EVs and the solar panels in the houses? That's the way. For example, Greg knows that Austin Energy is winning away from being a generation company. They're getting rid of all their CO2 producing entities. So they got Fayette and they got Sound Hill, and they're on the chopping block. At some point in the next 10 years, Austin Energy is going to cut the cord and no longer produce anything that is non-renewable. Is CPS thinking the same way? Is Denton thinking the same way? Are you going to rely on solar panels on everybody's house to manage your grid?
Well, I mean, we've already got to 100% renewable. Does that mean it's 100% renewable all the time? No, because at night the sun doesn't shine.
Right.
Right.
But you need dense batteries.
Yeah, but the battery economics are
It's not
getting
there.
there.
Right.
They're not there yet.
Right.
The cheapest way for me, and we have our own laboratory. It's called the Denton Renewable Resource Plan, and the cheapest way for me to do it is with quick starting peaking generation to back up. That's gas fired, but I can't build batteries at scale.
Right.
To store that solar and wind energy. I have to have something that I can turn on within 5 minutes to protect ratepayers from those high prices.
Right.
And I can't go buy a financial hedge for as cheaply as I can build a quick starting peaker. So that's the reality of where we are today economically.
Of course,
I agree.
You've got one of my old companies, Vistra, right now, at D. Cordova off of Lake Granbury. They had a quick start. They were the aeroderivative turbines, a little bit slower start than your internal combustion turbines at Denton. And they put in a battery system to take that quick frequency response, and then they back it up with the natural gas quick start turbines in case they run out of battery fuel. And charging in the batteries. So they're learning. I think we're looking at all combinations.
Right.
And seeing which one sticks to the wall.
Right.
Which one works. And it's going to change by region.
Richard, you have a competitive advantage. You own gas, natural gas, and electricity, and you are using your own gas to power your own peakers.
Right.
So do you see a world where you get rid of that for solar panels at the edge of the grid?
I think all utilities are looking at that future, what it's going to look like.
Right.
The same thing, like everybody said, it's an interesting challenge and question, and the same thing is like, where is hydrogen blends and the fuel mixes?
Right.
Where is hydrogen in the future? It's just a question that we're going to have to continue to watch and march, and technologies are going to change, and everybody's working towards, what happens after 2030. How do you keep taking the carbon out? It's just a lot. It's just a...
So Danny, you and I have been in this industry forever. I want to make you God for 30 seconds. What's the answer? How do we solve the grid problems right now?
Three parts in my mind. One is obviously batteries. Two is geothermal has to be used much more efficiently. It's a great resource. And then three is probably some nukes, some small modular reactors are probably appropriate in the future. And so that combination would pretty much nail this. I don't believe the solar model would work. I think it's too complex, too much variability. But I think that, having some real strong base load systems front-ended by batteries, so their only job is to charge those batteries, it really takes the volatility out of the system. You're no longer dealing with three-phase problems. I'll stop, but yeah.
Okay. Anybody else? Give them a round of applause for the gray panel.
Well, Andreas is coming up. I'm going to leave you with one thought. In 1879, when the first electric grid was put in Manhattan, what type of grid was it? DC. And it was a microgrid. So just like my ties, microgrids are kind of coming back. I'll leave you with that.
Come over and meet this guy.
Come over and meet him.
Come around and let's get a selfie here. I need a selfie with you, superstar.